So commutative property of addition and multiplication says that with strings of multiplication or addition, you can move the order of the numbers. So as an example, we know that 2 plus 3 is the same thing as 3 plus 2. If we want to make that more general, we can say for any number A plus any number B, it's going to be the same thing as if I had added B plus A. Okay? That's just a more general way of saying it. For any number A and any number B, if I add them the other way around, it's not going to change the answer. We could say the same thing for multiplication as well. We could say A times B is the same thing as B times A. So for any number A and any number B, A times B is the same thing as B times A. Aaliyah. Subtraction. Let's just prove it really quickly. I like this question. 2 minus 3 is equal to 3 minus 2. Change switch. Negative 1, change switch, positive 1. So it doesn't work. However, you guys probably have some ideas in your head already about what we can do about subtraction to make it work. Somebody's probably got some ideas, and we'll get there. We'll get there. I promise. Associative property of blank and blank. Associative property, another property that you learned last year. It works for two different operations. Somebody with a raised hand, name one of the two operations that it works for. Back to Brandon. Associative property does not work for subtraction. Luis, it does work for addition. And the other one, Callie, multiplication. Does anybody remember our definition or what the associative property says we can do? Jaquan. Not quite. There is definitely a link between associative property and commutative property. A lot of times when we use associative property, it's right after we use commutative property. And they do very similar things. Sammy? Yeah, we can put parentheses around the numbers wherever we want in strings of additions or multiplications. So, and when we're talking about parentheses, we're talking about grouping. So in my definition, I'm going to write it as in strings of addition or multiplication, we can group however we want. And right next to that group, I'm just going to put a set of parentheses to kind of remind me that when I'm talking about grouping symbols, I'm talking about parentheses. I can group however I want. So, as an example, if we have 2 plus 3 plus 4, I can add the 2 plus 3 first, or it's going to be the same thing if I add 2 plus 3 plus 4 and I add the 3 plus 4 first. We're going to talk about several ways in the coming days that these two properties are useful. Today we're going to be spending some time talking about when those two properties are useful for combining like terms, because that's part of our aim today. However, I do want to make sure that we can identify the properties and identify when properties are used incorrectly and be able to complete our work if we've done these properties, because this is the many different ways that you can show a deep understanding of these properties. So looking at the first one, it says, for each example, in one sentence, state, there's a word missing there, state, or tell me what property is being represented, and in another sentence, state how you know your answer is correct. So, looking at this first one, what property is being represented here? Katarine, how do you know?
Because it's the same thing, so they just switched the where they were.
Perfect. This is commutative property, and when you say same thing, what you mean to say is they are the same terms. And that's one of the vocabulary terms that you need to walk away with today. In addition, the things that are separated by the addition signs, each of them is called a term. Okay? So in addition, each thing that is separated by an addition is called a term. That is one vocabulary word that you need to walk away with today. All right? So going back to what Katarine told me, she said this was the commutative property. Sorry, this is commutative property. Notice the complete sentence because it asked me for a complete sentence. And Katarine said it's the same terms. But they are reordered. So we have the same two terms, 4a and 2a, they're just reordered. And we can do that with addition. That's the commutative property. It's glorious. It's wonderful. We'll see some of its glory and wonder today. Brandon. Brandon wants to do the next one. I'm totally okay with that. Brandon, do the next one. Okay, he says this is the associative property. And what makes this the associative property? I think you were about to tell me that, and then I interrupted you. Yeah, so very simply, we're changing what we're adding first. We were going to add the 3 plus 9 first, but over here, we've decided that we're going to add the 9 plus 12 first. No big deal. I got this. All right, and the last one, somehow I lost my statement here, so I'm going to give you one. And you're going to tell me whether this statement is true or false. And then you're going to tell me what property they were using. And I guess if it's false, that means they will have used it incorrectly. All right, so let's look at this. Start with determining whether this statement is true or false. Give me a kip yes if this is true. Give me a kip no if this is false. Falsies. Crescent, why false? Perfect, and that's exactly what I would want you to write. This is false. And Crescent says you can't use commutative property with subtraction. Now, let's move on. The second half of our aim today is talking about combining like terms. So we need to make sure that we have in our heads what are like terms and what are unlike terms. So let's look at this first thing. It's given you a situation. I want everybody to go ahead and write the expression that goes with this situation. So you're probably going to have to read the expression or read the situation on your own. You'll probably have to look at your paper to read the expression. Giselle, I'm looking at you. Edgar, what'd you write? Sorry, louder. Louder. I didn't hear you. That first part. Okay, 4 plus x. Is that it? It's two different expressions. Or was there something else supposed to go on between the two of them? How much does one apple weigh, Edgar? 4x times, he's saying times 5y. Now we're getting a little bit closer. What does the 4x represent, Edgar? What about the apples? Just how many or what? This is how many apples? It tells you how many apples there are. So what's the 4x represent? Because there are 4 apples. How much they weigh. So if that's how much the apples weigh and this is how much the oranges weigh, do I want to multiply that together to get the total weight? So if I weigh 15 pounds and, well, it's probably, I don't weigh 15 pounds. Let's, for simplicity's sake, say I weigh 15 pounds and Katarine weighs 10 pounds. You're telling me that our combined weight would be 150 pounds? What do you need to do with the weights, or what do you need to do with the weights to get the total weight? Total. That should be a key word for you. Total means you need to do what operation? Addition. Thanks, whoever said that for him. / let him think about it himself. All right. So this would be our expression. Now, it would be really nice if we could put this all together and just multiply once. And that's the idea of combining like terms, where we want to put things together. However, because those apples and those oranges weigh something different, we can't just put them together. We can't say, okay, well, this is the same thing as 9x. Or would it be 9y? Or would it be 9xy? So part of that confusion that you have around what variable you should put over there if you want to try and combine them should remind you that we can't combine them because they're what we call unlike terms. Okay? So if we think about this really quickly, the reason why we can't combine them is because when we're talking about 4 times 2, that's very different than when we are talking about 5 times 5. So these apples are way less than the oranges, so I can't just combine them together and be like, oh, all right, well, I have 9 apple oranges. That's not going to help me find the weight, okay? So, when we're talking about like terms are terms that have the exact same set of variables. Somebody give me an example of 2 like terms, a set of like terms. Aaliyah.
4x plus 8x.
Yeah, so I'm not gonna add them. I'm just gonna show them like this. 4x and 8x. That is one set of like terms. Somebody give me another set of like terms. Jaquan.
8x and 9x.
8x and 9x. I'm going to make things a little bit more interesting. Kip yes or Kip no? These are like terms, 9 and 4. Kip yes or Kip no? These are like terms. Yeah, absolutely. They have the same set of variables, which is no variables. Okay, let's try this one. 9x squared and negative 3x squared. Kip yes or Kip no? These are like terms. Kip yes or Kip no? These are like terms. Kip yes or Kip no? Before I throw a marker at the back of your head, you should be answering this question. Kip yes or Kip no? These are like terms. 9x squared and negative 3x squared. Form an opinion. It doesn't matter whether your opinion's right or wrong. Jacob, why do you think these are like terms?
Because they have the same variables and they're both squared.
Yep, so they both have x squared. That's their variable. Now you got to be really careful when we're talking about variables is x squared is definitely very different than x. Because if we think about it, x squared is the same thing as x times x. So that's a set. X squared is a set. It's a set of variables. One last one. Aaliyah, did you have a question or were you trying to come up with another set for me? What's your question?
If we didn't have the square root, it's going to be the same.
Cool. Aaliyah is asking if I had 9x and 3x and 9x squared if they were like terms. Let's look at that example. She's saying 9x and 3x squared. So let's look down here at this one that I have boxed in blue over here. Everybody, we're looking at the one that's boxed in blue on the board. So if you're not looking at the board, you're not ready to answer this question. 9x and 3x squared. Kip yes or Kip no? Do we think these are like terms? Looking for opinions from everybody. Do we think these are like terms? So if you're showing me no, you're absolutely right. And the reason for that is if we think about expanding this out, this is like 9x and 3x times x. So what we can see is that the 9x is a single variable and the 3x squared is actually a hidden set of variables. All right? Which brings us to our definition of unlike terms. This is where you can start using your wonderful knowledge of the English system. And you can say, okay, I've got a definition for like terms. And now I'm looking for a definition of unlike terms. Well, we know the prefix un means not. So there is one word that you can add to our definition for like terms. And if you add it in the right place, it will make a wonderful definition for unlike terms. So somebody give me a wonderful definition of unlike terms by only adding one word. Ivana.
Unlike terms are terms that don't have the exact same set of variables.
There were many ways you could have done this. This is the exact way I would have done it. They are terms that don't have exact or have the exact. Same set of variables. So one example that we have already come up with is this 9x and this 9x squared. We may also talk about 9x and 9. Okay, one of them has a variable, one of them doesn't. Another example we can come up with, maybe 9xy and 9y. They have a variable in common, but their whole set is not the same. Okay? These are unlike terms. So today, our whole idea here is we're going to simplify expressions by combining like terms, and we're going to be using all of the things we just learned. We just learned what like terms and unlike terms were. We learned what the associative property and commutative property were. And so not only are we going to be doing this work, we're going to be justifying our work as we go. And we're going to use the properties and the things that we've just learned along the way. So the first thing that we're going to do, and I'm sorry that I left a blank out for you, so add another blank down over here. So we're going to add another blank over here. And it's going to be for our first step. So our first step, and what's going to go in this blank, is that we're going to use the commutative property. We're going to use the commutative property. Now, I'm looking at this expression that I have, and I'm thinking to myself, there is something wrong here that's going to keep me from using the commutative property. What am I looking at initially and going, I don't know that commutative property is going to go here? Adrian. Yeah, there's a subtraction sign. However, this is where some of you really, really smart 7th graders have already had in your brain something we could do about this to make it commutative property friendly. Look at all those really smart 7th graders with their hands up. You're all really smart 7th graders, so you should all have your hands up. Giselle. Yeah, leaf change switch. So this is a wonderful tool that you've learned along the way that will allow you to change some things that aren't commutative property friendly into commutative property friendly. Now the whole point of using commutative property here is so we can get our like terms together so we can combine them. I always put my terms in the same order. I always put my exponent terms first, then my variable terms, and then my constant terms. Okay? So I'm going to start with my variable terms, and I'm going to cross them out as I go. And that's just to make sure that as I'm commuting, I don't forget anybody. No term left behind. So last, I'm putting my constant terms, and that's a definition that you need to walk away with today. These two terms, these two terms are what we call constants. And that's not a 14. I don't know why I didn't get rid of that. These two terms are what we call constants. And the reason that they're called constants is because no matter what the value of any of the variables are, these two terms are going to have the same value. They're always constant. It's always 3. It's always -4. The value of that term is not going to change if the value of x changes. This other term over here, x, well, if x changes, the value of that term is going to change. This 2x, if x changes, the value of that term is going to change. So they're not constant. All right? The next thing that we're going to do when we're going to combine these like terms is to use the associative property. And I'm going to use the associative property because I want to group my like terms next to each other. I want to add my like terms. So I'm going to group them together. And you can see that I'm grouping them using the parentheses. And that reminds me that I can now add these things together. Now, this is where the combining like terms information has to get together in our head. If I have this right here, the x has nobody to combine with, so it's just going to come straight down. But I can associate the 2x and the x. Now, if I have 2x and x and I want to add them together, how many x do I have? Show me with your fingers. Good. All of you are showing me 3. And what you aren't quite showing me is that you know that this is 1x. So anytime you have a variable that doesn't have a coefficient, that's the number out in front. If it doesn't have a coefficient, it has a coefficient of 1 that's just hiding there. We know this is 1x. So we're going to add that to our 2x. So we have 1x and 2x, and so together they are 3x. Over here with our constant terms, we have 3 plus -4. Be very careful. That's more negative than it is positive, so that's not just 1, that is -1. And then there's one last step that we can do. We don't necessarily have to do this. But most mathematicians will do this because they think this is a little bit simpler, is we can actually take this, and this is something you've never done before with change switch. You always change switch from subtraction to addition. We can actually use it the opposite way. And the reason why I'm going to do this is because when I change switch this addition of a negative, it changes to a subtraction and switches to a positive. You can see that we end up with one less symbol here. And so it looks just a little bit cleaner, a little bit simpler. Okay? Both of those answers are fine, but you might find on a test your answer choice is the subtraction one rather than the addition one. They mean the same thing. We know that because change switch works both ways. Okay? Questions about our work for today? Fantastic.